right. Hey, now we got everything going, I guess. Sorry for taking so long. I had to use my phone to see if we're going. Anyhow, hey, this is Tom, AF7J, Ham Radio Hobo here. Gonna have to figure out how in the heck I set this up. This is the first time using the OBS studio. I guess there's an update, but anyhow, how's the audio and video quality there, Todd? Am I doing all right? Can you see me? Give me a thumbs up. We're going live here. It's 3:44 in the evening, and see, I don't know if we can type in and see if our chat will come through. I'll say hi to myself via the phone. Looks good. All right. I'm gonna have to somehow edit this. So anyhow, today I was on the Ham Radio Clubhouse, and we were talking about field day operations. Sorry, it's a little hot out. And one of the things I brought up was Bandpass filters. So I've got one of these Bandpass filters. Probably can't see it because the camera spelling is going to be wrong, but it's a Dunestar, and this one is model 300-14. Dunestar makes bandpass filters. I believe they're out of Oregon. Let's see if let's see. That's Discord. We'll get the Discord down. I don't know if I can. It's the first time using this, but anyhow. So with what we've got hooked up here, antenna analyzer, MFJ antenna analyzer, and our Dunestar -14, which means it should go to 14 to 20 meters, and then back here in the back, right here is the bird dummy load, and that's where the other half of the coax is connected to. And so basically, what you would do to check your frequency range, of your oh, well, you can see this here. Right now it's at 13. Might be better to do this on the phone. But what you do is you check your frequency response by adjusting your frequency. So right there at 14, we'll see 13. So if we go to 13.1, the SWR is going to be fairly high. So it's blocking 13.1, not allowing that through. But if we start going to, about 13, $13.8. There you go, 13.8. You get low SWR. And then if we go like to 14, $14.224, we'll say there. You'll see that SWR moves around there. Almost should probably have put the black light on. But the idea here is to test your frequency range to see if the dummy load, to see if the see how well the resistance is and the SWR is. And so when we're at lowest SWR with that filter on is at 13.8. Then if we increase it to like 14.5, then we start getting, a SWR of 2 to 1. So that's how you would test a bandpass filter. Let's see what else we have here. The wife, obviously, sneezing. It's still hotter than you know what out here. Wish I had the screwdriver. Let me see if I can get the screwdriver. Let's see if Todd's still there at the CVS pharmacy. Live chat. Is that for VHF or UHF? No, that's for HF. So these bandpass filters are for HF. So that's why it would be 14.22 megahertz. So that bandpass filter, what a bandpass filter does is, like for field day, if you have somebody that's doing CW on 10 and it's interfering with your 20-meter voice contacts, then it's only going to allow it's only with the way the SWR works there is it's got a coil in there and then some rectifiers and stuff like that. I should probably take it apart to actually show you, but it's got find the screwdriver. Turn the antenna analyzer off. The screwdriver is around here somewhere. Boy. Maybe I put all the golden screwdrivers away. But what it does is allows for that particular frequency to go through. So you can transmit through it. These are low wattage. These are only able to about handle 100 watts. You don't want to do any heavy duty wattage with them. They do make ones that can handle more wattage because the coils wires are thicker and can handle more of the load being transmitted through there. I imagine you do get a little bit of loss because what it is kind of like a trap system to where it's only allowing that particular frequency to go through. So that's let's see exactly what bandpass filters do. HF band RF bandpass filters. Here's some from ICOM or an LCOM. What the? That's not what I want to do. It's just giving us items. So, like AM broadcast stations transmitting in the frequency range from 550 kilohertz to 1700 kilohertz cause havoc with HF and VHF receiving operations, often inducing carriers modulation, broadband noise, and other disturbances into dedicated equipment. Such interference can frequently be heard mixing with other received signals in the shortwave bands and are commonly overwhelming from modern receiver broadcast rejections. So you like have a station that is next to you, you want to attenuate and reject that signal that's coming in. Say like this is going to allow the 20-meter band frequencies to come through to your radio and allow them to go out. You can transmit and receive on 20 meters without having adjacent stations next to you that are broadcasting to interfere with you. Wish there was a wiki. I'm sure there's a wiki. Let's see if Wikipedia. Ants on the Bandpass filters. Wikipedia. Bandpass filter redirect. Okay, it's the Q factor. In electronics, a signal processing filter, usually a two-port circuit device, which removes frequency components of a signal, an alternating voltage or current. A bandpass filter allows through components in specific band frequencies called a passband, but blocks components with frequencies above or below this band. This constraint with a high pass filter, which allows through components with frequencies above specific frequency, and low pass filter, which allows through components with frequencies below a specific frequency. And digital signal processing, in which signals represented by digital numbers are processed by computer programs, a bandpass filter is a computer algorithm that performs the same function. The term bandpass filter is also used for optical filters, sheets of color material which allow through specific band of light frequencies, and acoustic filters which allow through sound waves of specific band and of frequencies. An example of analog electronic bandpass filter is a RLC circuit. An RLC circuit is electric circuit that consists of a resistor, R, and L, inductor, and a capacitor connected in series and a parallel. In series or in parallel, the name of the circuit is derived from the letters that are used to denote the constituent components of the circuit, where the sentence sequence of the components may vary, I guess, or whatever. But anyhow, so you're just adding this into your antenna circuit design so that that you're not having the QRM, which QRM is on the Q code list on Wikipedia. It says, "Are you being interfered with?" or "I am being interfered with." So QRM, if I remember right, the M was the hint that was used like on the test. I think it was either technician or general, or maybe it was extra. But anyhow, the M referring to man-made, something that is within your control, and QRN, which is nature, which let me know if you can control nature. Some people have been trying to do that for quite some time, but I haven't been able to deal with nature in a way that I can control it. Or if you do try to control it with the lightning rod, you end up having a key fall on the ground and your wire kite and your antenna kite and your kite antenna is going flying in the air. I always think of Benjamin Franklin when I started looking up kite antenna. I was like, oh well, that's pretty much what Benjamin Franklin did. Is he had a kite with a key. Of course, I don't know if he was using the conductive wire like you'd use for a kite antenna, but um, so yeah, there's not too many people think about that, but there's also ones that you can make. You can make your own bandpass filters. Um, there's different. It looks like there's different types. Uh, let's be for sure. Bandpass filter types. High Z antennas. DX Engineering makes one that's $48. Um, Pause Train. Low band systems from DX Engineering, $399. What's the $399 one? Gives you a rating of. Okay, so this one looks like from reading the zeros right for $400 for a low band system HF transmit bandpass filter, the F2007-B, for 40 meters, about $400. So this sucker has to be hooked up. That's weird. You'd hook it up to 12 volts. Must be to dissipate the heat when you're transmitting 2,000 watt. Um, um, so yeah, when you have multipliers for field day and you're having multiple stations, you don't want transmissions interfering with you. Of course, the logging software that people are using with networking, usually you can send in the chat box or look and see of all the stations that are connected to each other. Which would be fun if we can do this on here, share our screen. Where are we at? Can we share a desktop? Windows capture. Scene 2. What did that do? Let's see what that did. Change things. Nope, we're still there. We've got manage. We're here on YouTube. Let's see. Well, allow me to share the desktop. Well, obviously not. It's not switching over that way. Yeah, if there was a way just to share, this is totally different. It's OS, OBS, scene transition, start streaming, settings. Show confirmation dialog, enable, hide, show, make projectors, save, output, video. Is that gonna do it? Hey, there we go. I think we might have it. So now you can see what I'm seeing. Yep. So if I go here, yeah. So there we can type in Bandpass filters for QRM. Yeah, and seeing here's the different websites. Bandpass filters. So there's Wikipedia that I was reading about. See how it allows that's our live stream. We won't stay there. $26 subscribers. So we're making our way. There's somewhere else I was going to show you. It's that home button. Yeah, here's the one you can make by yourself. So this is what's inside, basically. You've got a capacitor. So you've got your one side goes to the shield and goes to this side of the circuit, and then you've got your center conductor that connects to one lead of a capacitor to the toroid inductor with the wire, and then a capacitor to ground, it looks like, and then a resistor of some sort. Then it goes over to the other toroid, and then capacitor, and then and then that. Let's see if it gives us a build on this. This is so there's your circuit. So you got shield to ground, then it goes to C1, which is capacitor. So that's your center conductor. And then it goes to inductor. One end of the inductor goes to ground. Then it goes to another inductor here, L2. And then it goes to another capacitor right here. And then the center conductor goes to another capacitor there. The other half goes to ground. Then it goes to another inductor, which goes to capacitor. And then the center goes out. And so your case obviously needs to be metal or have some kind of ground path to where the grounds connect to each other. And here's the parts list here. So we have the values obviously change between the frequencies, it looks like. Let's see, it is inductors. So, like if you wanted to do a 160 meter one for 1.75 megahertz, it tells you the toroid you need, a T68-6, and then a T80-6 core. And then this talks about how many turns you need for the different frequencies for winding. And then there's your ratings, what they should be at. And there's a little bit of math that goes in with it. There's a kind of a pictorial diagram of how it works. This N is obviously your center conductor. And then this out is your center conductor. And then, of course, what's not shown is the ground there. So that's just a pictorial circuit diagram of that. And then this is a schematic of a 5-pole Butterworth bandpass filter. The same construction technique as used for the 3-pole filters should be used when building 5-pole version. So Butterworth is kind of the design. I'm sure if we're just kind of doing the Cliff Note version of this. But this looks like September of 1988 QST. The PDF file. Do your multiple transmitter field day or contest efforts suffer from in-transition interference? These handy and inexpensive filters can help. And this was written by Lou Gordon, K4VX, out of Hannibal, Missouri. So that's what brought me on this whole thing, was that, and then going out with John W7JCA out there at the ranch, and experiencing, what the heck's going on? Why is this happening? So, and here's one ugly filter. Yeah. So he's kind of done the same thing, but he's used coax here. And this is kind of handy. So if you have, so what he's done here, if you look at this picture, is he's made out of a, he's went to Home Depot and got some Schedule 40 PVC here. And what he's done is he's taken some coax and done his turns there to make his some people call it a choke, but actually it's an inductor because it's coil again. And then he's got his capacitors there. And then he's got his other ends that are grounded to chassis. And then, of course, a bunch of... so what this is the same kind of setup. You got three L's, inductors, and capacitors. You're just... And this one is using an old computer power supply case. And there's the same kind of schematic. Okay. Then some of that bleeds off on L2. And then you get another capacitor. Okay. And then it goes to L3. And then some of that bleeds off to that capacitor. And then you've got another capacitor. And you got L4. So let's see. It looks like 1, 2, 3 on that one. So I don't know where the fourth one is. But anyhow. This one talks about how to build it. And this one was Nashaba NVARC Ugly Filter Project. I'm not even going to say the say the name. Here you get this page, and you got general construction notes. Bam. Okay, so here we got some more pictures, and now you can kind of see what he's done there. Looks like that's his 40-meter version. There you go. There's a real close-up of it. Winding and mounting coils. Nothing interesting there. Using the PC power supply case. Of course, yeah, you want to make sure any of the capacitors you have in there, and you know, clean everything up so you don't get zapped. And the power supply, of course, don't try to plug it in because you're just using the case. Looks like. Is this the other one? Kits and parts. Oh, here's another one. Same kind of thing. Clean up your signals with bandpass filters. These inexpensive, easily built filters can be the buffer you need between signals you want to hear and those you don't. What? Joe next door, he's pounding on his CW. I can't hear you. Wow, he's got a complete table here. I like this one. Look at that. Wow. Looks like it was a QST or something there. Yeah. 1998. June of 98. He's even got thing. Could do the same thing with mine. Let's see. Did I transition right now? We back to me. So I could do the same thing there. Todd, ding ding, chicken dinner. Gotta run. Store for pickup now. See you later, 73. Before you go, I'm doing world on. Oh wow. Didn't know that. Wow. So the world conference server on Papa system. So it says before I go, I'm doing the world on the Papa system on channel 5 since the world and Highgate is down. I gotta get up at 5 a.m. to go live at 6 a.m. Hawaii Standard Time. So there you go. This is cool. Screen sharing. Never thought of that. Anyhow, let's see what else we transition. We transition back. We can transition back. There we are. It is back. Okay, cool. So if we go like this, bam, there we are. And more stuff there. I should probably put these little deals in the chat. How would I do that? Okay, go over here. Switch my account. Okay. There's that one for everybody in the chat. So you can. Probably should mute this so I do not hear myself. There we go. What else? Yeah, oh, not that one. Here's another one. All right. So now we got all that done there in the chat. If you don't mind going live. Let's just do another one here. Studio. There we go. How about this one? Remote hams. I'm going to show you some stuff here. So this is the Remote Hams website. what you can do here is you can sign up and so what this allows you to do is to go like, let's see if I can find it. Okay, you still there? Okay. Yeah, we're still there. Still there. Yeah, we're still Let's just do that. There we go. Okay, so now we're there. We can go like this. Echo. A little bit of echo. Now let's see if it will transition. Mm-hmm. Then transition to the settings. Fade to black. I wonder what that. Hmm. Well, anyhow, maybe we'll have to try this some other time. Um, Hope you enjoyed the video. Thanks for everybody that's been subscribing. 26 subscribers. That's pretty cool. And I guess we'll end the stream and let everybody go. Maybe. I don't know. Let's see. Is it going to go to this one? Nope. I think I've gone live long enough. Have a good one.